Hey everyone, it's Sam. Today we're going to be talking about calculating z-scores. And a z-score is something that helps you understand how far away from the mean a value is with regards to its standard deviation. We're going to use some financial signals, and I think that's going to be an interesting way to calculate z-scores and see how they're important. So let's get started. So I just have a Jupyter notebook here. And this is going to allow us to sort of dive into some data, and I can show you easily and quickly how a z-score works. We're going to be using some macro financial data, something called the HYOAS, the high yield option adjusted spread. This just calculates the difference in yields from more junk bonds or more risky bonds versus U.S. Treasuries. So it shows sort of how the risk appetite of credit is in the U.S. Economy. Higher spread means that more people are away from the riskier credit, sort of a risk-off situation. And lower numbers usually means more of a risk-on situation where people are more into higher yield assets. All of this I have gathered from the Fred database. You can make an API call to it and download it into your local machine, which is I have done. I have a big database full of financial data and macro data that I use to do sort of these analyses. And it's sort of just fun to look at. So for calculating a z-score, let's just get the let's get a data frame here of from the macro. I have it as HYOAS, and we're just going to start from 2000 maybe, and we'll load in the data, and we'll just do a head call in here just to see, make sure the data comes through. It's coming through. And all of these helper functions basically are just doing SQL calls to my time series database that I have and pulling these values out. So we can just do a quick plot on this to recreate that one graph we just saw on the Fred database. So we'll just look at the value and we'll plot it. Okay, you can see you can see here that that's pretty much the same as here. And so if we wanted to see the axes, obviously, if we wanted to see x equals date and y equals value, and then maybe we want to make it a little bit bigger because I want to see it a little bit wider. So we'll do 15.7, and then we'll check it out, and we can see, okay, this is looking pretty much exactly the same. And that's interesting, but it's not that interesting because for us, looking at something like this, you can see these values as 2.5 to 5. 2.5 to 5 is a doubling, right? And 5 to 10 is a doubling, and 10 to 20 is a doubling. So we're not seeing magnitude changes here. We're just seeing absolute value changes. And what we really care about is the magnitude change, how fast or how big a change is in real terms, not just the value change. So if you wanted to see something very simple way to make this a little bit better, we could just make this a log graph. And then that's going to at least even it out a little bit. That's going to show things scaled correctly in terms of magnitude. So we can see how big of a change, for example, right before 2008 crash happened, how quickly this accelerated up into, sort of danger zone, as opposed to this graph where, yes, you see it moving, but it looks almost the same as these other movements here, and sort of hard to understand exactly the magnitude of the change. And so that's why log scaling is sort of interesting and can help with this information. Another thing is, I'll just move this down here so you can see a little bit better. Another thing that's good to do is to look at rates of change. These are just absolute values, but really what we want is a rate of change. So for example, let's look at how it changes over a 30-day period. So 1 month. And we'll call this rate of change, and we'll just do a quick, let's see, df value, rolling, no, percent change, periods equal window, and then we'll just multiply it by 100 to get an actual percent as opposed to a decimal. And then let's just graph this as well. So you can see now, this is a little bit more interesting. You can see now where things sort of jump up, and the jumping up obviously is showing high rates of change. You can see this giant spike, which I guess maybe you know, maybe you don't know, but you can see that this is during COVID, during 2020, and where things changed extremely rapidly. Obviously, the economy and everything was very different then. And so this is sort of interesting, and this graph is, I think, is helpful and nice to look at. But I think what we want to do is sort of see like how this rate of change differs towards like what is the normal rate of change, and also like how high and how low away from the normal range it is. And that, I mean, you can think of that as obviously the distance from the mean, and then how many standard deviations away is it from the mean. And while we could do it over the entire data set, I think it's much better and much easier to understand if we look at just specifically the mean and the standard deviation in a look back window of a year, because we want to see how much this rate of change has accelerated from a close time frame. If we look at the entirety of the data set, then we're going to have a mean that's competing with, 2008 financial crisis, and maybe credit conditions have changed in the last years. Things have changed. There's possibly policy shifts. You don't understand all the nuances of something that's changing unless you sort of do all that research. But really the easiest way to do it is just to sort of give it a tight window, and then your calculation changes as conditions change without you having to understand exactly why the conditions have changed. So I think we can do a look back window of, let's just do 252. Well, let's just do 365 1 year. And then we'll get the mean. So we'll get the mean here. ROC mean equals ROC rolling window. So it just backfills it. Look back up now, look back, and then get the mean of that. And then we can do the same thing with the standard deviation. And then this is where the calculation of z-score comes in. The z-score is simply the value, current value, subtract minus the mean, and divided by the standard deviation. And we're dividing it by the standard deviation to normalize it in terms of the standard deviation. This needs to be called standard deviation, not mean. And then, so let's just graph this and see what it looks like. Yeah, okay. So this is a little bit more interesting, right? We're seeing things in terms of the mean, and then we're seeing how big up changes are from the standard deviation. This is not a beautiful plot, but we're going to make it a little bit more beautiful here. So these are the z-scores, and you can see like a 2 here means like 2 standard deviations away from the mean. A 4, a 6, and 8. This data isn't a normal distribution. Financial data is never a normal distribution. So when you hear people saying stuff like, oh, that was an 8 sigma event, or this was a 6 sigma event. What they're trying to say is, oh, this was 6 standard deviations away from the mean, meaning it's almost mathematically impossible that this event happened. The problem is the standard deviation percentages within this threshold, idea is dependent on the fact that you are working with a normal distribution. We're not working with a normal distribution here. And so something like a 6 sigma event sounds crazy, but as you can see here, like it's happened, 3 times in the last 20 years. So it's not mathematically impossible, and it's possible it's going to happen again. So let's clean this up a little bit. Let's go back to making just a normal plot. We have the plot x equals date, y equals z-score, big size equals 15.7. And then that's gonna be a little bit better. Z-score. And then I'm gonna add, and so you don't have to watch me type this out, I'm going to add a few lines here that are going to make things a lot easier to see and sort of more interesting. I'm just going to copy and paste these, and I'll explain what they do. But basically, this is just adding horizontal lines, AXH line at 2 and -2. And those are just 2 standard deviations away. So you expect things to be roughly inside of that. So that's why we use 2. And then I'm adding just some labels for like interesting events that happened. These are the market tops. So in 2007, the market peaked in October 8th. In 2020, it peaked in February 19th, and also in 2025 in February 19th, which is sort of interesting. So let's run these. And then you can see that you have sort of this nice z-score map of what is sort of outside the range of the norm being 0. And obviously, I think if you look at these peaks, and if you go to, looking at this S&P 500, for example, you can see sort of where these spikes coincide with some drops. Now, it doesn't mean the market drops. Obviously, that's just the way it is. But when it's a big drop, that's when you sort of want to be, aware of it. And so, as you can see here, in 2008, it spiked a lot right before the big crash. In 2020, it spiked a lot, and then and afterwards too as well. So you can see that's maybe a few days later. And same thing with tariffs, a few weeks later. So in 2008, actually, it was a much better indicator because it sort of let you know before things happened. And in 2020 and 2025, you could sort of think, okay, things moved a little bit too quickly for this to be a great indicator of whether the market was going to crash or not. But you can still see that it's a nice confirmation, this spike, that things are at least in troubling times, and maybe that's sort of a risk-off situation. So that's the z-score. And I hope that was interesting to you. I think a lot of statistics is really interesting, and even just as a fun adventure down a specific macro signal that some people use, I think it's a fun thing to look at because it sort of gives you an understanding of what's out of the side of the normal, what's inside the normal. And I think we're going to be diving in a lot more of these coming soon. So if you're interested in this, I wrote a Substack article about the z-score that's just a little bit, has some of the code in it. So you can check that out and subscribe. And if you're interested and you like this video, please like and subscribe, and I'll see you later.